In this video, we will discuss Pascal's law. So let's say we have this container that is filled with water whose density is 1000 kg per meter cube. Now from this initial level of water, the points A, B and C are at a depth of 1 meter, 2 meters and 3 meters respectively. Assuming that the acceleration due to gravity is 10 meters per second square, the pressure at A would be 10,000 pascals, the pressure at B would be 20,000 pascals, and the pressure at C would be 30,000 pascals. Now let us understand what happens when we increase the pressure on this container. The best way to increase pressure is to add some more water. So here we have added a water column of 1 more meter above the already existing water column. This would mean an addition of pressure of 10,000 pascals. Now from this new level of water, the points A, B and C are at a depth of 2 meters, 3 meters and 4 meters respectively. That means the new pressure at A would be 20,000 pascals, the new pressure at B would be 30,000 pascals and the new pressure at C would be 40,000 pascals. What that means is there is an addition of 10,000 pascals of pressure at each and every point A, B and C. So what we can conclude from this observation is that when pressure on the water was increased by 10,000 pascals, the pressure at every point in the liquid also increased by 10,000 pascals. So to generalize, we can say that when there is an increase in pressure at any point in a confined liquid, there is an equal increase at every other point in the liquid and the container walls. This statement is called Pascal's law. Now there is an alternative statement of the same law, and it states that in a fluid at rest in a closed container, a pressure change in one part is transmitted without loss to every portion of the fluid and to the container walls. Now, since this statement is more in terms of the transmission of the increased pressure, this statement is called law of transmission of pressure in fluids. Now let us look at the applications of Pascal's law. Pascal's law finds its applications in hydraulic machines such as a hydraulic jack. A hydraulic jack is used to lift a large and heavy object such as a car using a relatively small force. So how does a machine such as the hydraulic jack work? A typical hydraulic machine consists of 2 containers of different sizes connected to each other. The entire set of containers is filled with an incompressible fluid such as water or oil. A piston of cross-sectional area A1 is fitted upon the smaller container and a piston of cross-sectional area A2 is fitted upon the larger container. When a force F1 acts upon the smaller piston, the pressure in the set of containers increases. This increase in pressure would be equal to F1 upon A1. According to Pascal's law, this increase in pressure is transmitted to the larger piston and results in an output force F2 on the larger piston. Since pressure is equal to force upon area, the force F2 would be equal to the pressure P multiplied by the area A2. When we replace the value of P, we get the equation F2 is equal to F1 upon A1 multiplied by A2. In simplified form, this equation becomes F2 upon F1 equals A2 upon A1. In this equation, the ratio of the output force F2 to the input force F1 is called the mechanical advantage of the hydraulic machine. This is because the output force F2 will always be greater than the input force F1, since the area A2 is always greater than A1. And now, the summary of this video. An increase in fluid pressure is transmitted without loss to all points in the fluid. This statement is called Pascal's law or law of transmission of pressure in fluids. The working of hydraulic machines such as the hydraulic jack and hydraulic brake is based on Pascal's law. In these machines, a small force on the smaller piston causes a large force in the larger piston. The ratio of output force to input force is called mechanical advantage. So that's all in this video. In the next video, we will learn how to solve numerical problems on Pascal's law and hydraulic machines.